Well, thanks for joining me in my shop. I'm about to start something new. Here, let me take one out. One of these is partially open already. I'll take the one out that isn't. I think this would be, 1952. Ooh, that's just some debris rolling around on the cone of the speaker. 1952. Pontiac car radio. Two of them. Two car radios and a very detailed manual that comes with it. GM Autoradio model number 510. Fantastic. This is partially apart because the tubes have already been tested. And the tubes are fine. There it is. Looks a little different than the other one. Just a second here. So the basic dimensions are identical, the opening here and the like, but the buttons are different. They're shaped differently, and numbering is a little bit different. Hey, this one goes from the low end of the band to the high, and this one goes from the low end to the high here. GM Autoradio. This one says Chieftain. Chieftain. Another really obvious difference is this fitting, which would press up against the inside of the dashboard, I guess, or the front. Actually, this would be coming right out the front of the dash. I don't mean this would be sticking out. This would be behind the metal of the dash, but a lot of car radios, as you know, are up on the dash this way. This one's actually vertical. I think probably they are straight replacements for each other, even though they look a little different. So maybe they manufactured radios of the same basic dimension for years. For obvious reasons. I don't know. This will be the third car radio I've seriously worked on. First one was when I was maybe 14. Can't say it was too serious. And basically, I took one apart. Not like this, though. Not this type. And more recently, I did one on video on my channel on a transistor car radio from the late 60s, early 70s, somewhere around there. It was not a very pleasant experience. But this won't be bad. Ooh, this won't be bad. You can already see the bright yellow capacitors. That's someone else's work, and it would appear that after performing some capacitor changes, the radio won't function. So I know the tubes are good, the vacuum tubes are good, and the most important thing is the vibrator. So I've already tested the vibrator and it turned out to be good, but I'm going to repeat that test just so you have some idea of what I'm doing here. And I'm going to bring it down to size here. Vibrator, you can read up on these in on the internet just why radios have vibrators, but the short story is it changes the DC coming from the car battery to a cheap crummy AC that'll still make its way through a transformer, and so they can raise the voltage up into the range that the tubes need. Since in this car, the car battery is only 6 volts. It's not even 12. And you want, the tubes need, somewhere around 100 volts, 90 volts, 100 volts, something like that, minimum, to operate, so. So this is a DC supply, variable supply. There's 4 pins on here. Let me just grab my own meter. So you should find, I think, open circuits everywhere and a low resistance between 2. Let's see if I've got it right. Open, open. There we are. Low resistance there. So by all means, I'm not going to explain too much about it. You can certainly find great demonstrations of these things, but I do want to test it. So these 2 are the prongs that showed it was around 50 ohms on my meter. Is that what it was? Onto it. I'm going to turn up the voltage supply, and I think what I'll do is I'll hold it up near the microphone here. That's 6 volts there. That's the other microphone. There you have it. I don't know for sure that the contacts are making contact properly, but I think it's a good guess that yes, there's nothing wrong with it at all. So we're going to plug this back in. And what that means is there's only one thing left to do, and that's apply power. This was not easy to get out. This was really held in by the clips here. Whack! That was the clips closing. Wow, that's really held in there. The tubes are not clipped in any way. And interestingly enough, let's see. No, they're basically sitting with this kind of angle. So as the car bumps along, these things are receiving vertical forces and some horizontal too, but a lot of vertical shocks coming into them. You think they just fall out after a while. There's a little more of the work that was done on the radio there. Okay, I don't think there's too much more to do. We should really have to put an antenna on it. Wow. Let's see. Okay, that's great. I'll just put the radio like this. Speaker like that. Oh. Oh, okay. Just wanted these the speakers fit into clips here. The clips are really loose. Tighten that up a bit. There. One wire had come out and I thought, oh my gosh, it's broken, but no. Okay. Now, where am I going to get 6 volts from? I can get it from my little power supply here, but my power supply will only put out about 1.5 amps. I just don't think that's anywhere near what this is going to need. But in the interest of fun, we'll see what happens, in case I'm mistaken. Or I'm going to have to think up where I'm going to get 6 volts from. 12 would have been easy. Negative ground. This is down to nothing right now. Put it on here. Oh! It's already drawing maximum power. I don't... Even with no voltage. So this looks like a dead short to my power supply here. Already. 2 amps. I can do 2 amps, but I don't know how long I can do it for. So it's drawing just over an amp right now. And I don't think there's any hope that that's anywhere near the amount. Well, yeah, I don't think that, the vibrator hasn't even started. So, okay, I'm gonna have to come up with some way to feed 6 volts. DC. Well, even though I searched and thought hard, I just do not have a 6 volt power supply that can power this radio. So instead, I've got to get a little bit creative here. I've got this power supply. This one will do 15 volts at 4.4 amps. That's probably adequate. It's good enough for an initial test, that's for sure. So what I want to do here is to cut that power back, and this is the dumbest way to do it, but this is pretty much my only way of doing it. I've got this big high wattage resistor, and it's variable. I can slide this up and down. And this is only a few ohms. Not even sure. I'll have to. Not even sure. Let's find out. In case I'm mistaken about things here. Oh. Just getting ready to read the amps with the meter here. So here we go. 37 ohms. I think that's great. I can make that much less. 10 ohms. Perfect. Put this back on current here. Now, this is the where the output of this ends up. And this thing I made so many years ago. Find out the polarity on here. And what the voltage really is on it. So, plug it in. We're using this meter here. 15, and it says minus there, which means I have the leads reversed. Come this way. Positive is the top wire. Okay, unplug the power supply. So we want the positive there. Okay, so so we want this to be 6 volts. That's the plan. Okay, I think we're all set to give it a try now. Oops. Switch is off. I'll now turn on the power supply here. Power supply voltage is showing up on this meter. The reason is the switch is off. There's no current flowing in the circuit. There's no voltage drop on the resistor. So over here, instead of reading something less than 15, we're reading pretty much the whole thing. Now, turn on the radio. First off with the power. If it's over 9, power goes off right away. 7, I'm feeling okay. There we go. Okay, so we've ended up with a quarter of an amp and third of a volt. That doesn't make sense. Quarter of an amp, that was nothing. So we're going to reduce the resistor here and see if we can bring this up to the range of a couple amps. Maybe this will come to life. Just turn the power off. Line this up here. Okay, try it again. Expect this to be higher and this to be higher. I really don't understand this reading. So now we've got a half an amp going in. So what should I really expect here in terms of current? One, two, three, four, 5 tubes. 2.5 amps, I would say. That'd be my guess. Let this get warm. Did get a little bit warm. Seems like I'm way off in resistance though. This is, I can't get this that much smaller and be pumping a heavy current through it. It's going to turn into a heater, a radiant heater. Gotta keep my eye on it already. Okay, so we're ready to go for another shot. I'm guessing this is going to be 2 volts this time. Let's see. One volt, 1 amp. Ooh. What was that? Okay, power's off. Okay, what, it doesn't matter what it is I'm working on. Something new always shows up. Okay, so what was that? Wow, that's a tough one to explain. If there's an intermittent short going on in here, it might have made the bulb behave the way we saw it, become really bright. The bright light is either a short in the radio here that's developing, or something funny going on with this power supply. If I was trying to draw 4 amps, 5 amps out of it, if I was seeing that on here, I'd be quite concerned that I'm to expect something funny happening with this, including it shutting itself off. But don't know. I don't know if there's some kind of safety feature on one of these. Kind of doubt it. There was a short circuit that was clearing, or it wasn't a short circuit, it was actually the connection being made. This thing wants to draw a lot more power than what I've imagined so far. What do I do now? A bigger power supply. Something that can put out 10 amps. Okay, here's another one. Output 13.8 volts DC, 6.5 amps continuous, 10 amps at 50% duty cycle. Okay. Current through the radio, voltage across the radio. First with the switch off, so we should see the full output of this power supply. Okay, I think it's off now. Not sure though. So here we go. As soon as I apply power to it, maybe it's switched on. So nothing. Okay. Now I'll switch it on and apply power. This should go and just show the output voltage of the supply. 13.75 or 13.8. 13.8. Wow. Down to 1 decimal point. And no current flowing. Okay, so power off. Okay, we'll switch it on now. Ready to turn on the power. Above 9, switch it off. Well, it's pretty much the same as the last one, but I don't see the light flickering. Fat chance. And this is reading negative here. Okay, so yeah, it's reading negative just simply because I have the leads reversed here. Let's correct it. Okay, it's gotten fairly warm. Let me read the resistance of this and see where we're at with it. Okay. Wait a minute. I have another meter. 13 ohms. So basically I'm trying to match the resistance of the radio, and drop roughly half the voltage coming from the supply. So the radio is generating 8 or 10 watts of heat, probably much more in fact. I need a resistor that's going to dissipate that kind of heat. It's got to be down quite a bit lower than this one. Like a 2 ohm 10 watt resistor. A 2 ohm 10 watt resistor. Well, I'm going to lessen this one first. Because this guy can get pretty hot without getting injured. That'll give me time to realize the folly of my ways. Okay, so that's going to be 5 ohms, something like that. There it is right there. 6 ohms. This time I would expect 4 volts or something like that to show up, and maybe an amp and a half here. There we are. Are we ready? Radio's on, but the volume's turned down. Turn the volume up just a little bit. Okay, there we go. $54. 2 volts, one, let's see. Then I'd be stunned if the radio worked. 76. That's hot. Should cool it off. Break it. Oh, we're starting from a cooler temperature. 40. It's going to get hot this time. Everything ready? Yeah. Here we go. Time for the tubes to heat up. And if the two elements get hot enough, then the tubes will start to conduct. It'll pull another amp. You see this thing will start dropping. It's kind of interesting that it's climbing. $70 degrees C. 3 volts. If I remember right now, I had to get the vibrator up right around 3 or 4 volts. Wait a minute. Look at the pretty big drain on the power supply here. I wonder if this has dropped. There's no heat in it. The actual current being drawn from it is only 1.4 and it's good for 6. This has climbed all the way up to 3 now. There's lots of heat coming off that. You could parallel it with another big resistor. Let me just turn off the radio and see if that'll light. Wow. It's not making sense.